Madam, shall we start, madam?
Okay, sir.
Good afternoon to one and all. Today afternoon session will be conducted by Dr. D. Suji on the topic self-curing and bacterial concrete. I want to give a small introduction about today afternoon resource person. She is Dr. D. Suji. She completed his BE Civil Engineering in PSC College of Technology, Coimbatore during 1985, and she did her ME Structural Engineering in the same college, PSC College of Technology, Coimbatore in 1997, and she did her PhD in Civil Engineering in Satyabama University, Chennai during the year 2009, and she has published 25 international journal papers, and in international conferences she has published 18 number of 18 number of papers, and in national conference she has published 20 number of papers. Also she is having membership in professional bodies like Indian Society for Technical Education life membership, and a life member in Institution of Engineers India, and also she is a fellow of Institution of Valuers India, and some other professional recognitions she is having are one reviewer for International Journal of Earth Sciences and Engineering, and she awarded two PhD under guidance, pursuing 6 PhD research scholars at Karpagam University and 4 PhD research scholars at Karunya University, Coimbatore, India. And she received grant of rupees 60,000 for organizing a one-day seminar on sustainable energy technologies and low carbon buildings for climate change mitigation, sponsored by Ministry of Earth Science, New Delhi, and received a grant of rupees 30,000 for organizing a one-day workshop on seismic hazards, mitigations and preparedness, sponsored by CSIR, New Delhi, and received a grant of rupees 40,000 for organizing a regional workshop on seismic retrofit of reinforced concrete building structures, sponsored by Ministry of Earth Sciences, New Delhi. Then received a grant of rupees 30,000 for organizing a 2-day national conference on the topic drought, climate change and groundwater sustainability, sponsored by Ministry of Earth Sciences, New Delhi, and received a grant from DFT under Waste Management Scheme, rupees 53.4 lakhs at PSG Technology. And also, at present, she is working as a professor in PSG College of Technology, Coimbatore, Tamil Nadu, India. So, I welcome Dr. D. Suji to present his and deliver this lecture on self-curing and bacterial concrete. Welcome, madam.
Thank you, sir. Thank you very much for a nice introduction about me. At the outset, let me thank the principal of Sakti Polytechnic College and head of the department for giving me an opportunity to share in this session or address in this session. So I'll try my best to share the knowledge, what I have experienced or what I have learned through my research activities so far about these two topics. Only I think I in self-curing concrete, only few projects have been going on, and in bacterial concrete, already have two scholars have awarded their PhD. One is yet to submit. So I welcome all the participants for this Atal online FTP program. So let me share my screen. So can you able to see my screen, sir? Is my screen is visible?
Yes, madam. Yes.
Okay, fine.
Yes, ma'am.
Okay, sir. Yes, okay, fine. Thank you. So let me start the session. So the first session is about, actually it is bacterial concrete. It comes under a broad domain of self-healing concrete, right? So it comes under the broad domain. So if you look at, if you goes with, yeah, fundamentally before getting into this bacterial concrete, you must have some understanding about what is self-healing. So let me begin with the introduction. So I have arranged my presentation in this way. So a brief introduction about self-healing concrete and self-healing approach and ways of applying bacteria in concrete, mechanism of applying the healing agents, effect of bacteria on the properties, and small hydration kinetics to make you understand. A small case study, time permits, I will show, otherwise we can discuss in the later stages, and some practical applications, and let us conclude the session. So as we all very well know that due to the availability of the raw material, affordability and durability, concrete is a widely used material all across the globe, and it is also having superior compressive strength also. However, majority of the or lot of concrete structures, including infrastructures like bridges, dams, etc., invariably suffer degradation and deterioration over a period of time, right? So this is due to the permeation or percolation of water, which affect the efficiency. So efficiency here, I mean, it is the strength of the concrete. So one of the causes of the major deterioration, such deterioration, is the formation of cracks, right? So the formation of cracks are in, let me highlight. Okay. So the formation of cracks are inevitable in concrete. So the cracks may be either at micro level or it may be at macro level also, which causes passage for dissolved particles in fluid. Some unwanted acidic substances and gases can also permeate inside these cracks. So what happens? These materials and other aggressive substances, naturally it deteriorates or the performance, or it may cause deterioration in the materials. Either the aggregates or cement matrix may be get deteriorated or get damaged by these aggressive substances due to some chemical reactions also. And finally, it may also affect the reinforcement also, like corrosion may be the major source of such damage, right? So in interaction between this concrete and its surrounding environment plays a major role which affects the long-term performance or determining the long-term performance of the concrete, right? So now, so how to control some, see, if you look at the cracks, if you consider cracks in concrete, there are different types of cracks, possibility of cracks that occurs in concrete, either due to physical reasons or chemical, or maybe due to some thermal causes, or maybe due to plastic types of cracks may occur, sometimes due to external loads. Some structural cracks can also occur. So there are various causes by which the cracks are formed in the concrete. Now, due to, see, for this reason, what we are doing, we civil engineers, periodically we are doing maintenance, right? Inspection and maintenance are invariably coupled with the construction, right? So inspection and maintenance techniques are increasingly drawing attention in the recent period, and implementation of this continuous inspection and maintenance also very much difficult, especially in the case of large scale infrastructures, right? If you consider a huge bridge etc. It is very difficult to do this such type of periodical maintenance because of large fund involved due to huge manpower needed, etc. Some other factors like sometimes the location of damage in the affected structure makes it to, I mean, it is very difficult to reach or locate the damage in a particular structure. So, because of all these reasons, right, the concept of self-healing arises, right? So this concept of self-healing or autonomous repair by the structure itself reduces this maintenance effort with minimum labor, and some huge capital requirements may not be needed. So this autonomous repairing techniques are very well be adopted in the recent years, right? So in order to better understand these type of problems encountered during the construction industry, yeah, survey, I mean, like a type of survey was conducted in UK by Materials for Life EPSRC research project, right? So the three main objectives of this research were to identify the nature of concrete damage and the structure types of structures and the elements which are vulnerable to damage, and the effects of concrete damage and maintenance, and finally the approaches taken to address these damages in concrete and their impact, right? So the market research also explores the potential application of self-healing cementitious materials and the benefits in their use. So their findings will be used to develop the future developments in this lead research area, right? So this research provides a basis or gives an idea about the various damages by which the various types of cracks could be occurred in concrete. Now, as I told you, conventionally, there are different types of materials and methods have been adopted to control the cracks or to mitigate the cracks or to arrest the damages which occurs in concrete, right? So various repairing techniques are as of now it is available, but they are highly expensive and time consuming process, right? Concrete repair normally refers to bringing out the structure to its original form or original to regain its original strength, right? So it can be classified either as a cosmetic repair or it may be sometimes rehabilitational repair. It depends upon the type, right? So there are these repairing techniques or methods are classified here based on types of cracks. So you might have studied the various types of cracks like live cracks, dormant cracks, voids, hollows, and honeycombs, scaling damage, spalling damage. We cannot simply straight away use a single recovery or damage retrofitting measure to make it applicable to all type of cracks. So it depends upon the type of defect, and accordingly the repairing methods are varying. Similarly, the materials also, if you look at, there are different types of materials are used here. So depends upon the materials, depends upon the defects, suitable repairing methods has been identified, and for that particular type of technique, suitable materials are also selected. So this is our conventional way of selecting or using repairing the cracks which is formed in the concrete. So there are different types of repairs being adopted. Few examples like dry pack method for deep and narrow cavities, and pre-placed aggregate method for restoration of large areas such as walls and foundations and spillways, and sometimes partial or full depth concrete replacement can be used for patching for different types of concrete, like shotcrete and shotcreting and graniting is also another type. and epoxy mortar injection is also used, and cement mortar injection, and sometimes crack sealing and filling by epoxy injection is also preferred, and surface protection by overlays or by various sealing coats can also be used, and pre-stressing for water tanks, slabs, and for deflection control. So there are different varieties of techniques are available. So depends upon the type of defect we can choose. Though there are different varieties of techniques and materials are used, it is we have certain drawbacks also, because there are these techniques is not unique for a particular type of product, right? We have to identify a suitable type of defect, accordingly we have to use it. Additionally, the use of chemicals causes harm to the environment also. It's not an environment friendly material. Some types of techniques are not environment friendly. When analyzing the durability together with the assumption like sustainability point of view, right, we have to find out some alternate like technique which is more friendly to the environment, and it should be cost effective also. So because of all these reasons, we have to go with an alternative approach which is called as self-healing approach. So the modified cementitious modified form of the conventional concrete by using such type of approach is called as self-healing concrete, right? So self-healing concrete is defined as the ability of the concrete to repair its cracks autogeneously or autonomously. So there are two methods by which the self-healing process can be done. One is autogeneous and another one is autonomous. So it is called a self-repair. So another name of this self-healing concrete is a self-repairing concrete, right? So it imitates the nature, like it imitates the automatic healing of our body wounds by the secretion of some kind of material. It mimics the nature, so it is a biomimic material, right? So to create self-healing concrete, some special type of materials such as fibers or capsules, which may contain some adhesive liquids, are dispersed into the concrete matrix. So when cracks happen, so the fibers or capsules which are mixed along with the concrete, conventional concrete or cementitious system will break, and the liquid contained in them will then dispersed outside and hit the crack at once. So this is a simple mechanism, right? So as I told you, this is can be compared with our nature, the wound initiation in our body, blood clotting, and cell proliferation, and finally wound healing. So it is somewhat mimic the nature, and hence it is called as self-healing. So this is the schematic illustration of self-healing process in biological systems. And so the upper one is self-healing structures. Biological system is A, and B below said one is the which is conventionally used in our systems, right? So where we can imitate or we can mimic the nature or compare it with our conventional system what we are using too. So there are certain major mechanisms of self-healing approach, right? So as I told you, self-healing mechanism is defined as it's a process, right? It is a process. So it can be any process we can follow, but by using that one, by the material that finally the material that itself uh, finally uh, finally ends up with a recovery, and hence improvement of a performance after an earlier action, right? That reduces the performance of the material, right? So any material, any process, either autogeneous or autonomous, we can follow, but finally the material heal itself, right? So this is the basic definition. So there are different mechanisms have been introduced or done by many researchers during the past few decades. However, see, the history of self-healing phenomenon is, tracked back to ancient structures also. So many of our ancient structures are constructed long before, like 10,000 years, 20,000 years before structures. Even now it is stand still, showing very few damages, and the majority of these structures are like it was constructed using lime mortar, and only constructed with locally available materials. So it heals the cracks itself, right? So this intrinsic property of concrete that fills the cracks with some hydrated pozzolanic binders or some form of some crystalline materials is called as autogeneous healing. So the healing is the done by the material itself, and that crack healing is initiated by the formation of some hydrated pozzolanic binders, right? So after realizing this whole concept of healing and sealing, healing first, and sealing and healing, sealing by the formation of pozzolanic binders, thereby the material heals itself without any external activation. So the materials, understanding these two processes, a new domain, an improved system was also invented by the researchers, which is called as improved autogeneous self-healing. So we have autogeneous, we have autonomous, I'll explain later. So autogeneous healing is also called as intrinsic healing. So here the material or the system itself heal the cracks itself by the formation of some new pozzolanic binder system, which is formed, right, by the material itself, which is called as autogeneous self-healing. And autonomous self-healing, we are adding some engineered materials in the system, so that whenever the formation of cracks occurs, the system starts activating. The materials are engineered additions, what we are added to the concrete enters into the picture, and it will cause, or it will create some new binder system, and that will heal the cracks itself, right? So understanding these two, there is a new domain or new area of research which is called as improved autogeneous healing. So what is autogeneous and autonomous healing? So autogeneous healing is also called as natural self-healing process, right? So this process can partially repair concretes, right? It can partially repair concretes through various processes, right? So here a picture is shown here. So here some initiation of crack is there, and this crack, the healing of this crack or formation of, right? So the formation of new additions or formation of new substance or pozzolanic binder in the form of some white substances on the deposited in the crack is followed by 4 steps, right? So there is a 4-step mechanism there for the intrinsic healing or autogeneous healing. It is called as natural healing process. So in the first step, what happens is the formation of, see, there is a water here. See, once the crack is open, we have a cement paste, right? So this cement paste, sometimes it consists of some unhydrated cement particle. So whenever the crack opens and whenever it meets the water source, moisture, this unhydrated cement particle starts hydrating. So during the hydration process, a byproduct called calcium hydroxide is also parallelly it is formed, right? So this calcium hydroxide reacts with the CO2 that is which is available in the atmosphere. That CO2, once in the presence of moisture, dissolves and forms CO3, carbonic acid, and this calcium hydroxide reacts with that CO3 and finally forms calcium carbonate white powder, right? So this is a four-step process, right? So initial formation of calcium carbonate, and sometimes debris in water and loose concrete particles, broken particles in the concrete also sometimes deposited inside this path. So it will also act as barriers for further movement of any other substances, and swelling of this hydrated cement paste, because calcium carbonate gets swelled up once moisture is more, right? So further hydration of the unhydrated pozzolanic particles takes place. So this is the four-step mechanism. This is called as natural healing process. So in autogeneous healing, the self-healing process takes place with the use of products formed in the presence of carbon monoxide, dihydrate and water. And calcium silicate hydrate is our hydrated gel, which is formed due to the hydration of unhydrated cement with water, right? So in addition, directly introduced sometimes expansive measures such as magnesium oxide, and sometimes bentonite clay can also be added in order to achieve high sealing efficiency of cracks with an initial width of about 0.18 mm. So if you have a cracks of micro cracks of this range, definitely all these cracks will autogeneously healed by natural healing process. Now, what is meant by autonomous self-healing? See, autonomous self-healing, according to Rylam Technical Committee, is defined as the process of healing with the material components that are specifically in concrete for this purpose. That means they are called as engineered additions. So they are called as engineered additions. So some engineered additions, right? Some type of additive materials in different forms are added to the cement or concrete to activate or to further improving the natural healing process. So that is called as autonomous autonomous self-healing process, right? So among there are different types of autonomous sealing process are there, right? There are different processes by which it can be created, right? One among them is what I told in the beginning, it is bacteria based, right? So apart from that, there are few other methods are also there to bring into this autonomous healing process. So let us look at that one. So there are different materials used to bring in this autonomous healing process. One is utilization of bacteria. So as I told you, there are two processes. One is autogeneous and another one is autonomous. So autogeneous repairing itself, right? It is natural. Whereas in the autonomous, we have to give some additional engineered materials or substances to bring bring in the self-healing ability or process, right? So in the autonomous healing process, there are different types of materials are used, right? So what are all those different types of materials? Let us look at one by one. So the major material which is used for this type of autonomous healing is the bacteria, right? And that results is not all bacteria, so only some selective type of bacteria could be used for bringing in the self-healing property. Apart from that, not only this bacteria, some other mineral admixtures is also being used to they have a capability of forming this crystalline or expansive products while it is being initiated, right? Then encapsulation of chemical healing agents. Sometimes some types of resins or polymeric substances could also be uh, used, right? Um, to mixed in the form of some capsules, like we are using capsules or pills to in the form of drugs we are taking for some body wounds or something like that, right? So similarly, these polymeric resins or some type of glue can also be used to bring in this mechanism. So they will be disposed in the matrix. So due to some excessive loading or due to some internal stress, while the concrete gets cracked, naturally uh, mean like substances get fractured, and the release of such gums or substances, so that will that will enters into the self-healing process and heal the cracks. But some like drawbacks are also there to introduce such type of materials. One is the high initial cost of these techniques keeps them off the table when it comes to industrial applications. Not it is for demonstrating laboratory level experiments, it's okay, but while it is being commercialized, right, for upscaling the laboratory demonstrations, it will be of higher end. It will more cost will be involved. So it is not commercialized in many of the countries. Then cultivation of bacteria, more research more in-depth research is needed to upscale this laboratory demonstrations. Then cultivation of bacteria or tailoring encapsulation techniques with the materials that should withstand the harsh and alkaline environment in concrete may sometimes become more expensive than expected. We know that microorganisms like bacteria, it should be capable of our pH value of, cement for liquid is around be at 13, nearly 13. So this microorganism should be, it should withstand or alive in those harsh alkaline environmental conditions. So identifying or cultivating that bacteria in the harsh environment is also very, very more research is needed than expected, right? So novel approaches were carried out by researchers in this field that indicates that the potential that lies in this mechanism. So only the mechanism is very well being appreciated to, overcome the above said drawbacks. So the self-healing concrete, as I told you, is of three broad domains. One is natural self-healing process, and biological self-healing process, and chemical self-healing process. So as I told you, the natural self-healing process follows the process that is blocking of cracks. Blocking of crack, orbit forms, calcium carbonate, precipitation, and blocking of the cracks by impurities, and further hydration of unreacted cement or cementitious materials, and finally expansion of the hydrated cementitious matrix, and the crack and the final finishing of all the cracks. Then biological self-healing process is a different one, right? So as the chemistry of this self-healing process, I have already explained, right? And now foundation of this. So this is the biological self-healing process using different types of bacteria, and chemical self-healing process using capsules, shallow pipettes, and sometimes vascular networks. So let us see one by one. Then there are two different modes of using chemical self-healing process. One is passive mode and active mode. And while coming to this biological self-healing, biological precipitation of calcium carbonate due to bacteria, and precipitation of this polymorphic iron aluminum silicate is also possible due to some researchers. They have conducted experiment and they have concluded. And the precipitation reactions are carried out by using, even nowadays fungi is also attempted or used as a carrier to heal the cracks. So fungi as well as bacteria is also, these types of microorganisms can also be used. Different microorganisms, families, there are different families of microorganisms are used for various researches, mesophilic and thermophilic microorganisms. And in this under this domain, there are two another It is anaerobic microorganism, aerobic microorganisms. I'll explain all these things later. So there are various causes induces self-healing mechanism. As I told you, mechanism is the heart of the success of any of the self-healing concrete, right? So the success becomes only the based on the mechanism. So the various causes inducing the self-healing mechanisms are physical, chemical, and mechanical. So the physical causes include swelling of the cement matrix near the crack opening due to the absorption of water by the hydrated cement matrix. So we have a cement matrix, right? So once the once the crack is open, some micro cracks are open. So it should be the the cement matrix should be in a position to absorb the surrounding water. So that is the physical cause. The chemical causes can be attributed to the two main processes. One is continual hydration of the Portland cement, right? As well as the formation of calcium carbonate. This is another second case, right? The chemical cause. Then the mechanical causes finally ends up with autogeneous healing. So it fills the cracks with the fine particles originating from the broken concrete surface itself, or it may be transported to the concrete by water. So these three causes induces self-healing mechanism, right? So this is the model of 5 steps taken place within these three processes: physical, chemical, and mechanical. Swelling, continued hydration, calcium carbonate formation, the mechanical cause broken off from fracture surface originally deformed. So these mechanisms are common to all types, whether it may be natural or biological or chemical. This is the basic mechanism, right? So this is the chemical reactions that I have explained, right? So the formation of calcium carbonate, blocking the impurities, hydration of unreacted cement, expansion of the hydrated cement. So these are this is the natural process. Now let us come into the chemical chemical self-healing process. So the chemical self-healing process is one of the novel technique. So the chemical self-healing process, here we are using the chemical substances. This process is another way of healing the concrete by injecting the chemical components into the concrete. So there are several researchers. They have attempted different types of chemical substances for their concrete. This is called as artificial healing. So the previous one is natural healing. This is called as artificial healing. Some researchers, they name it as artificial healing. So to design the chemical self-healing materials, various types of glues are used, right? So the major techniques used with this chemical self-healing process is glues, and this healing treatments uses hollow pipettes, right? Hollow pipettes and vessel networks which contains glues, right? And the vessel networks uses encapsulated glue. So I'll explain with the one technique, right? Vessel networks and hollow pipettes which contain glue. Here it is explained, right? So in chemical self-healing concrete, we have two modes. One is the active mode. So this I have explained earlier. There are two modes. One is active mode and another one is passive mode. This first mode is called as active mode. So this mode uses vessel network which is connected to the external glue, right? So the it consists of some networks within the concrete, and this vessel network is used for distributing the glue, right? It supplies to the concrete. So this distribution of this vessel network facilitates the concrete whenever any crack initiation occurs. So that will be injected to the tank, and finally the cracks may be sealed up in the external source. Excuse me. So there are two ways, like a vessel network and sometimes hollow pipettes. So the first one here it is called as hollow glass fibers. See this one. So this is called as hollow pipettes. So this hollow glass fibers acts as a pipettes, and like our pipetting that we are using in our laboratory. And this hollow pipetting and another one is the vessel network are two forms of this uh, uh, two forms of the chemical treatment method. So many researchers have been used these hollow pipettes using with various length scales. See, for example, polymers are normally used as glue substances. So the glue which exists in this hollow pipettes has ability to mix with fresh concrete. Like it should have some consistency to mix with the concrete. So huge research has been carried out in order to make the substance compatible with those of this those of the concrete mix, or to make a adhesive, make as an effective adhesive through this technique. So huge research has been carried out. So basically the idea comes from, it is also like mimicking, it is mimicking our nature, like so our blood vessels in the human body, and it is mitigated in hollow paper. So it is our blood network is similar to this paper. So this is one concept under chemical self-healing process. Actually, other than this hollow pipette technique, the second one, which is attempted by some other researchers, is this tank containing glue through this like vessel network through the concrete system. So you can understand very well about this mechanism here. So this is the crack being propagated into the concrete. So crack being propagated into the concrete. So the vessels connected to the external tanks. So vessel containing glue. Once the formation of crack is initiated, the rupturing of vessel by crack. See, there are minute networks are propagated inside the concrete area, and once the crack is initiated, due to internal stress, rupturing of the networks. I call this as vessels, like our similar to our blood vessels, rupturing of vessels by the crack. And once it consists of already a glue-like substance, and naturally once it is cracked, the glue-like substance enters into the crack and heals. So this type of like research has been carried out by few of the researchers. But what I have told you earlier is that upscaling of these mechanisms to bring into reality is very, very difficult because of the cost involved and the huge research technical gaps are there. So in order to sort out all these problems, still further research is needed to bring into reality. And this is encapsulated glue. So this is another form of technique. Here, as I told you, it is like small capsules, like small size capsules, micro capsules, or it may be of nano capsules, which carry the glue as a self-healing agent. So these capsules may be dispersed in the concrete matrix, right? So one researcher maybe he attempted like this microcapsule technique for self-healing concrete. So this initiation of crack, and when this crack meets the micro encapsules, then naturally due to the internal stress it may fracture or break. So this material which is filled in the capsules can enter into the cracks and it may heal the crack. So there are different ways, like vascular technique is there, and another type of chemical self-healing process, artificial healing processes, this micro-encapsulated healing process. And this is the schematic diagram of crack healing by microorganisms. So this is called as biological concrete or bacterial concrete. So it is a new objective or a new area in civil. It is a new area under the civil engineering, under modern concreting technology. Right. This bacterial concrete is basically depends on the microorganisms, right? So microorganisms are used for majorly used for this bacterial concrete. So small microorganisms, when sometimes these microorganisms can be directly dispersed in the concrete, or sometimes some carriers are needed to carry this bacteria into the system. So different mechanisms are tried, and one of the mechanisms here is microorganisms are filled in the form of a capsule, and this capsules are be dispersed in the concrete, and while expansion and further stresses releases breaks the capsules, and releasing of this microorganisms causes the healing process, right? So there are this is the SEM micrograph of a SEM analysis of a conducted research. So this research shows that there is formation of new phases after the initiation of crack. So formation of C, this is one. So this is the formation of crack, and once the that is microorganisms are presented in the concrete due to microbiological precipitation. It is calcium carbonate has been precipitated into the crack, and it heals the cracks, right? So this is the SEM analysis of research conducted by some researcher. So the biological self-healing process attempts with the use of microorganisms to design the self-healing concrete, or which is called as bioconcrete. So bioconcrete can grow almost, see microorganisms we can see everywhere. So wherever you can see, definitely there is some microorganism. So microorganisms are invariably present everywhere. So this microorganisms are presented in soil, water, oil reservoir, acidic some springes, and even industrial water comes. It consists of some type of microorganisms. The type of microorganisms are different, but everywhere we have microorganisms spread all over the world, right? So the use of microorganisms to design self-healing concrete has been suggested by several researchers, right? So nowadays, this modern concrete, under the modern concrete, many researchers are attempted to go with this biocomplex, right? And biological self-healing concrete, as I told you, in comparison with this artificial healing process or chemical healing process, it is very well be sustainable one, and it is also an environmental friendly process. So microorganisms are mostly divided into three important categories. One is like bacteria, fungi, and viruses. See, now two types of research has been attempted so far. One is the bacterial based, and another one is fungi based. So the among these microorganisms, some special strains of, well, not all bacteria we cannot make use of our bacterial concrete. Only some special type of bacteria are suitable for using or having the healing property, or enters into this mechanism and forms the calcium carbonate precipitation. Not all. So only some selective bacteria are used. So these special strains, we call that name as strains. So some special strains of bacteria are capable of precipitating certain chemicals which are used to design the biological self-healing concrete. So the precipitation of this precipitant, or the formation of polymorphic iron aluminum silicate and calcium carbonate, are the most important processes used for designing the self-healing concrete, right? So major one is calcium, carbonate, and some researchers also attempted to convert or to make the mechanism through the bacteria, the formation of this iron aluminum silicate. So this is also a good adhesive substance. So polymorphic iron aluminum silicate formation through this bacteria is also attempted by many researchers, right? So there are different process routes are there. One is microorganisms can be added to the concrete through different approaches. Addition of microbial broth directly into the fresh concrete. That means when the microorganisms of certain quantity is dispersed in concrete, it will cultivate itself within the concrete. That is called as microbial broth directly into the fresh concrete. And in sometimes some spore forming bacteria are also there, because in order to withstand the alkaline environment, the spore forming bacteria are very effective. So this spore forming bacteria is also attempted to use as a bacterial for mineral precipitation. Sometimes immobilized form onto silica gel or activated carbon is also being used. As I told you, these microorganisms can be used either in the mobilized form or in the form of immobilized form. The mobilized form, it is active always within the concrete, whereas in the immobilized form, whenever the opening of crack and when it reaches to the oxygen source, it will enter into the reaction. That is called as immobilized form. So in the form of silica gel or in the form of activated carbon. So activated carbon, it is now it will consist of n number of micropores on its surface. So it is spongy in nature. So it easily provides a space for these microorganisms to adhere on its surface, and this will be a very good carrier of this type of microorganisms for self-healing approach. Then encapsulated form are using some vascular networks, as what we have used it in the chemical method. This can be used in the encapsulated form, or sometimes it can be used in the vascular network. So this is the So what are the controlling factors for growth or the activation of this bacterial precipitation? One is the pH. pH means the concrete, the pore solution. It has a pH, so it controls. So it depends on the type of cement what we are using. So the pH, the temperature and moisture content of the concrete are typically not suitable for the growth of bacteria, right? So it should be right in a right. No, it should be most favorable. Actually, the high pH, high temperature, a high moisture content, all these things are unfavorable. Only the optimal parameters are selected for a particular type of microorganisms used for. So it is not also uniform for all the microorganisms. So the type of bacteria what you are used uh, depends or needs different optimal conditions that you have to check out. Hence, in certain cases, resistant form of bacteria that I told you earlier, that is called as spore forming bacteria is used instead of using fresh microbial broth, right? So alternatively, encapsulated microorganisms can also be used to withstand the harsh condition of concrete. Encapsulated microorganisms are highly expensive and complex method, and the use of vascular networks also encouraged to distribute the microbial broth throughout the cementitious matrix is another way of protecting the microorganisms from improper conditions. So, however, all these things are complicated and subjected to lack of constructability using current technology. So, all these are in the theory level only. Next one is identification of bacteria and development of bacterial concrete. So this is a typical bacterial cell wall, bacteria and the precipitation using the single wall microorganisms. So microbial mineral precipitations coming from the metabolic activities of useful bacteria in the concrete. So not all, as I told you, not all microorganisms are suitable. Only mineral precipitating bacteria are selected. So this process might take place inside the cell wall or sometimes outside the microbial cell, or sometimes it may be happened within the concrete itself. And bacterial activity frequently causes a change in the solution chemistry, so resulting in oversaturation and mineral precipitation. So the application of these biological concepts to concrete could lead to the development of novel material known as this bacterial concrete. So historical perspectives, bacteria are actually it is a single cell species. It occurs in varying forms and sizes. They are omnipresent in everywhere in the ecosystem, and it is also available in organic matter, plant and animal life bodies. And typically there are 40 million bacterial cells in 1 gram of soil, and the farmer one who discovered the bacteria is Antony. In 1676 itself, they have discovered a bacteria single lens by using a single lens microscope, and Christian Gottfried is introduced the word bacteria in 18th century, and Louis Pasteur in 18th century showed that the process of fermentation is caused by the proliferation of microbes, and Pasteur was an early advocate of the germ theory of disease along with his contemporary Robert Koch. So Pasteur, based on his name, there is one bacteria, Bacillus, this Bacillus patchouli is another one type of microorganism. And the gram positive and gram negative are the two broadly classified cell wall types of bacteria named from the cell reaction. So gram strain, there is a method of differentiating bacteria. So a test procedure for diagnosing the taxonomy of bacterial species. So gram positive and gram negative are the two broadly classified types of bacteria based on cell wall type, right? So bacteria are generally cultured in the laboratory using some solid medium or sometimes liquid medium, and solid growth media like agar plates are used to isolate the bacterial strain from pure cultures. However, liquid growth is also encouraged, like employed when growth measurements or high cell volumes are needed, then liquid medium is also encouraged. Then growth instead is, I mean, like if you stir the liquid media continuously, it will using this liquid as a medium to for the growth of bacteria. Sometimes easy to split and transfer, but it is difficult to isolate a single bacterium from the liquid medium. Bunch of this group can be easily split up, but isolating a single bacterium from the liquid medium, it is very difficult. The use of selective media can aid to identify certain organisms. There are several stages of bacterial growth. One is lag phase, stationary phase, death phase, and log phase. So bacterial growth normally follows all these 4 stages of development. So when a bacteria population first enters into high nutrient environment that allows for growth, then the cells must adapt to their new environment. See, first initial phase. So the bacteria is given some food, right? It has to grow. So it has to grow into some big numbers. So for that, some feed, some nutrient is needed. That is called as initial phase. So when bacteria population first enters a high nutrient environment, that favors the growth. So that cells must adapt to their new environment. Then the first growth phase is the lag phase, a period of slow growth. So that initially the growth of that bacteria or microorganisms, initially it will be slow. Then when the cells adjust to that environment, that high nutrition environment, and they will prepare themselves, adapt themselves, then the rapid development takes place. Then lag phase. The lag phases has high rates of biosynthesis. So proteins are created, that is called as biosynthesis. Proteins are created which are needed for rapid growth. So taking the nutrient, biosynthesis process follows. So proteins are created which are needed for rapid growth. Then the second phase is the logarithmic phase or log phase. So it is a lengthy phase. So also called as exponential phase. So during this phase, rapid exponential growth is shown, and due to the biosynthesis process, fast biosynthesis process. Then during this phase, the pace at which, pace here, what I mean is rate of, right? The rate at which the cells develop is known as rate of growth, and the time taken for the cells to double is known as period of generation, right? So during this phase, this rate of growth and period of generation is very, these parameters determines the efficiency of the microorganisms. Then nutrients are metabolized at maximum speed during the log phase until one of the nutrients is exhausted and begins to inhibit growth, right? So once all the nutrients gets exhausted, the growth is inhibited. So the stationary phase is the ultimate stage of growth and is caused by the insufficient nutrients. So if you go with stationary phase, there will not be any growth of microorganism. That means all the nutrients are used up, metabolized. So it is a stationary phase, right? So the cells decrease their metabolism and devour non-essential cellular proteins. So at that stage, there will not be any further growth, right? And there are different types of bacteria, Coccini, Phylla, Bacillus patchouli. There are n number of microorganisms. New microorganisms are identified day by day. So under a broad family, so there are different types of microorganisms are available by name. So the suitable chemical precursor found to be most suitable. As I told you, some nutrients are needed, right? So some nutrients are needed for the growth. So calcium lactate is majority of the researchers, they used calcium lactate as a source or feed or the nutrient for the microorganisms to grow further. So bacteria is normally classified based on 3 types. One is shape, then is another one is based on strain, gram strain, that is cell wall type, and third one is oxygen demand. So the based on the shape, it is spherical, rod like, spiral. So all the microorganisms, they are not unique. So they have different shapes, some spherical form, some rod-like, some spiral form, etc. Whereas cell wall type, based on the classification, it is based on two types, gram negative and gram positive. And based on oxygen requirement, it is aerobic, and it needs, some needs oxygen, some not need. So aerobic and non-anaerobic microorganism, right? And these are few types of bacteria used in concrete: Bacillus pachuri, Bacillus sphaericus, then Escherichia, Bacillus subtilis, Bacillus cohini, Balladanus, and Pseudophormus. These are all few types of Bacillus groups, normally Bacillus groups, fulfilling the required criteria for the self-healing property. And mechanisms, if you look at mechanisms, self-healing concrete is the result of biological reaction between non-reactor limestone and a calcium-based nutrient, which uses bacteria to fix the building. Very simple mechanism. The formation of basalanic admixtures, basalanic formation due to the entry of these microorganisms heals the cracks. So Bacillus bacteria utilized in conjunction with sometimes calcium supplement. Like calcium supplement is calcium lactate, that is the feed for the microorganisms to grow further. So these compounds are mixed into the wet concrete during the preparation itself. Then this can survive up to 200 years in a dormant state. Whenever it meets the favorable source for its growth, it opens up and uh, healing itself. So this is what our ancient historical buildings constructed some 10,000 or 20,000 years before could survive. So some type of research is going on based on this understanding. Like water flows into the fractures in the concretes when they emerge, and it is a source of supply of oxygen for some type of microorganisms. So the spores of the bacteria germinate and starts feeding on the calcium lactate, consuming oxygen, and the transformed into the neoprecipitation, right? So the hardening of the insoluble limestone starts depositing. So as a result, the crack is spontaneously filled without the need for external assistance. So another benefit of this procedure is that because of the bacteria heat oxygen to turn calcium into limestone, it helps to avoid steel corrosion due to fissures. So steel reinforced concrete structures become more durable. This is the cycle. So chemical process of bacterial or self-healing concrete, it is similar to our natural healing process. So initially calcium hydroxide is formed when water comes into the reaction with the unhydrated calcium carbonate. Unhydrated calcium in concrete right now. So unhydrated, whenever there is an unhydrated cement particle. So nowadays we call it a cement particle. In ancient structures, they have used limestone. So it also has some calcium source. So whenever this calcium source reacts with water, it forms calcium hydroxide, and due to microorganisms acts as a catalyst, and this calcium hydroxide combines with this carbon dioxide in the air. So carbon dioxide in the air combines with water, it forms some carbonic acid, and this calcium hydroxide takes the carbon monoxide dihydrate, and it forms like calcium precipitation, mineral precipitation. It is similar to limestone, right? So this process continues because of the additional water molecule. After that, the limestone hardens and fills the cracks in the concrete. So these reactions are governed by the chemical equations of this calcium oxide reacts with water, calcium hydroxide. This calcium source from the unhydrated limestone, and this calcium hydroxide through microorganisms, activated by the microorganisms, and it takes up that CO2, forms calcium carbonate. So this is the graphical representation of the reaction of calcium carbonate production in bacteria, calcium chloride and perchloride. So what are the challenges? So the construction community is not, no, see, there is a lack of knowledge or research in this microbiological process. And our construction community is not aware of that much biotechnology part in our hand. So bacteria are considered to be some types of bacteria. It needs lots of precautionary measures or understanding of the bacteria, its harmful effects. Everything is to the up to the root. It should be very very important. So some types of microorganisms are harmful to the health. So understanding of all this classification and types is very very important. So the product and performance of mineral-induced calcite precipitation, MICP is mineral-induced calcite precipitation, may be varied geographically and environmentally and require adaptation to the local conditions. So this MICP, nature of this MICP is not unique. So geographically, the different types of microorganisms are there. So one type of microorganisms which is available in US or UK is not available here. Maybe the climatic conditions may be different. So it is adapting the microorganisms in our local conditions is very, very important. So standard protocols need to be developed concerning the testing and acceptance criteria. And survival of bacteria in the high alkaline pH environment is very, very challenging one. Then encapsulation of bacterial cells using polyurethane well as well as silica gel and microcapsules is all highly challenging one. So reduction in production cost. So answer to all the above questions and problems must be found. So there is a huge technical gap in this area. But anyway, so those who are interested in attempting or those who are interested in this biotechnology and chemistry, it's a very good area, an interesting area. They can conduct some laboratory studies. They have uh, they have chosen this as a research area for their PhD, etc. Nowadays, many research publications are available in this area. So, due to lack of time, I could not share my research work. We attempted with some MSAN. We have isolated the bacteria from MSAN. We have used it for our efficiency to check with some mechanical properties and other things. So I could, due to lack of time, I could not continue the session. So still we have half an hour more. I think I can take a 10-minute break, 10 minutes break, and I will rejoin you again for the next session. Hello.
Hello, madam.
Shall I take a 10 minutes, sir?
Okay, madam. Can have 10 minutes.
Okay.
Participant, you please join after 10 minutes. Thank you.
எப்படி இருக்குங்க? ரொம்ப ஹை லெவலா இருக்கா? இல்ல ஓகேயா? சரி, சரி, ஓகே. எனக்கு என்னடா இது ஹையா போகுதா? என்னன்னு இது இல்லாம இந்த டாபிக் சொல்ல முடியாது. இல்ல இதெல்லாம் சொல்லலாம். ஓ! Hello, can you hear?
Yes, ma'am.
Yes, ma'am.
Okay, okay. Shall I start the session?
Ma'am, sir went to break, ma'am. We can start.
Okay, okay, okay.
Madam,
Yes, sir, shall we start?
shall we start? We can start, madam.
Okay, okay. So, good afternoon all again. So, in this session, let us speak something about self-curing coffee. So, as we all know that because of its low cost of the materials and affordability, again, concrete has been used one of the widely used construction material next to water, right? So because it has superior compressive strength as well as it has good durability, but spalling of concrete, crack, and corrosion of reinforcement is experienced by concrete construction elements. It becomes more and more serious problems in everyday, right, in everyday life. So, in order to, they want to conduct a survey. In US, they have conducted an elaborate survey, which indicates that 57% of pavement distresses occurs at early age, especially in bridge decks, and 40% of distresses are due to corrosion of reinforcement bars, and 31% of that damages, distresses, and the formation of cracks occurs in rich girders and others such as sulfate attack, chloride attack, freezing and thawing cycle. These are all other problems by which the damage occurs. So all the problems above should be eliminated, or otherwise it should be reduced to some extent. And for that we have to take some proper measures at curing stages. Here we are speaking about curing as an important parameter or the source or by which we can mitigate the durability issues. So curing is very important process by which many of the future problems could be rectified. So importance of curing. So curing of concrete is it is very important immediately after casting of the concrete to avoid potential shrinkage, settlement, and thermal deformation which occurs at early ages. So early age damages are more prone. Withdrawal of moisture, most of the water is taken for hydration. So this early age problems could be sorted out by proper curing. So proper curing is significant for concrete to satisfy the requirements of mechanical properties as well as durability. So improper curing ends up with more number of cavities or potholes, whatsoever it may be. So this will be the source for damage in future, reduces the mechanical strength as well as it reduces the durability of the structure also. So we have to go with an ideal curing process. So ideal curing process is creating an ambient condition of moisture, humidity and temperature to the structure, which unfortunately cannot be fulfilled in most of the construction projects. Though we are speaking theoretically more about curing, but real implementation, if you look at, this is very lagging. But lagging in the sense, the reduces the durability of the structure as a whole. So through traditional curing methods such as ponding, spraying, covering wet burlap, and plastic films, normal concretes can be used nowadays. But this is the traditional method, right? So traditionally we are using so many methods, wet burlap, spraying, etc. So many methods we are adopting. But all these methods, though we are adapting, finally does not ends up with an effective solution for our durability issues. However, this curing is the though it is we are by generic name we call it curing for the strength properties of conventional concrete. This curing, the terminology or the process is very important for high performance concrete. So high performance concrete is characterized by low water to binder ratio and high volume additives, sometimes silica fume may be used, sometimes fly ash may be used. So high volume mineral admixtures may be used to achieve the performance which we require for. So it normally characterized by low water to binder ratio. So we are using low water to binder ratio, but again we are encouraging more quantity of mineral admixtures, high volume additives. So on this condition, what happens is The penetration of external water is very, very difficult, and only superficial and traditional curing mode is attempted, like no. So these mineral additives, what is the mineral additives or role of mineral additives in high performance concrete is that during the hydration of the cement particle, so it reacts with water and it forms its own hydrated compounds, calcium silicate hydrate with different volumes based on like its mineral composition. Tricalcium silicate, it forms some certain percentage of CSH, and dicalcium it forms some percentage, like that. It depends upon the mineral composition. So during this hydration process, parallelly calcium hydroxide is a byproduct which is formed. It is a unwanted substance. It reduces the strength, and again it deposits near the transition zone, like between the aggregates, on the nearer parts of the aggregates it deposits. So once the crack initiates, right, so it easily, it is the weaker zone. So ITZ zone is the weaker zone. So this mineral admixtures, while we are using in this high performance concrete, so it consists of the like aluminosilicate materials, and this aluminosilicate materials fibers are combined with calcium hydroxide and it forms secondary gel. So this secondary gel, again it will be deposited in the weaker zone, ITZ zone, and it strengthens that particular zone. So naturally the addition of this pozzolanic admixtures like mineral additives forms secondary gel and makes the the entire concrete matrix as a thicker one. So on this occasion or on this condition, the penetration of external water is difficult to enter inside of the microstructure of concrete, because the inner portion of the entire concrete still consists of some unhydrated cement particles. It's a slow process. Does not happen eventually. So it is a very, very slow process. So while using this mineral additives, so the formation of secondary CSH gel, it forms a thick layer. It prevents the entry of this external water to get into this CSH membrane to get deposited in the capillary pores, or so many things which is not possible because of this mineral additives. So consequently, with insufficient water and outer curing water is inaccessible to the unhydrated cement particles, complete hydration is not at all possible. So what happens is a series of chemical shrinkage. What do you mean by chemical shrinkage? Chemical shrinkage is the CSH jellies in the, once the cement is mixed with water, it is converted into a porous solution. It is converted into a porous solution. The solution, the quantity of solution is more, right? So it is more, right? But once it is gets hydrated, the hydrated compound volume is less compared to the porous solution. So this is called chemical reduction. This is called as chemical shrinkage. So the quantity of hydrated compounds formed is less compared with this original porous solution. So the reduction of this original quantity is called by name chemical shrinkage. So this chemical shrinkage within the solution causes autogeneous shrinkage, and it causes premature crack. So this premature crack finally induces the degradation of mechanical properties and durability. So considering all these issues, this self-curing is very much be essential as a new technology, especially to high-performance concrete with low binder ratio. So now let us define what is meant by self-curing concrete or internal curing method by name. So different names are there, right? So the American Concrete Institute in 2010, it call it by name internal curing as supplying water through a
freshly placed cementitious mixture using reservoirs via pre-wetted lightweight aggregates that readily release water as needed for hydration or to replace moisture loss through evaporation of self-desiccation. So here a new name like self-desiccation is used. What does mean by self-desiccation? That is the water which is consumed by the cement particle to convert it into its own products is called as self-desiccation. That means it consumes the water which is needed for the chemical hydration. That is called as self-desiccation. So the American Concrete defines the self-curing or internal curing as the supply of the pre-wetted aggregates. They have mentioned lightweight aggregates, but nowadays we are move ahead with not only aggregates, but many other systems or processes are there to initiate this self-curing technology or method or process. So according to ACA 2010, it is through pre-wetted lightweight aggregates that readily release water, because like nature of lightweight aggregates is like it is highly porous. It has large number of micropores. Once if you dip a lightweight aggregate in water, the absorption capacity, if you take the weight of the aggregate without wetting and if you take the weight of the aggregate after wetting, that's a huge difference of water intake, right? So it absorbs more quantity of water. So this pre-wetted aggregates acts as reservoirs. Reservoirs here means source of supply. So it becomes source of supply whenever the system needs water. It will supply that water through some mechanism. So this is the definition as per American Concrete Institute, right? So this ACA and another definition, and this is a mechanism explained here about self-curing concrete. So according to ACA 308, the internal curing refers to the process by which the hydration of the cement occurs because of the availability of additional internal water that is not part of the mixing water. So you know what is the difference between the mixing water and hydration required water. There are two types of water that I tell you later. There are two types of water out there. One is chemically combined water, another one is free water, right? So this water, what is taken by this substances, special substances, which supply in future if the system, cement system, cement mortar requires for its hydration, then it will give away that water, right? So this is called as internal curing as per ACA 308. So according to this definition, curing can be divided into two types. Naturally, one is external curing and another one is internal curing. So you have two types. One is external curing, internal curing. So the conventional concrete curing methods are called as external curing methods, such as water curing, membrane curing. There we have different types of curing methods. We are preventing the evaporation loss from the surface, right? So these are all the techniques which are adopted in the conventional mode. So curing is taken to happen from the outside to inside, right? So in contrast, in opposition to that one, what do you mean by internal curing? Here it is also called as autogeneous curing, or it is also called as self-curing. Curing takes place from inside to outside. So curing takes place from inside to outside. This is the difference. So in the previous one, curing takes place from outside to inside, whereas here the curing takes place from inside to outside. So two-way moisture movement between the porous lightweight aggregate and porous hydrated cement paste allows for hygral equilibrium. See, the micropores, the calcium silicate hydrate is a spongy structure. It consists of millions of networks. It consists of millions of pores. So in between there are some hydrated products, some voids are there, some gel pores are there, some capillary pores are there. So it is an interconnectivity of all the types of pores within it, right? It's a spongy structure. So there is a spongy structure outside. There is a porous aggregate submerged inside that cement paste. So the hygral equilibrium is the main hygral equilibrium means the moisture movement, relative humidity of these two outside, that is calcium silicate hydrate system and this moisture, relative humidity of this aggregate. So the relative humidity of the system between these two is called as hygral equilibrium. So this hygral equilibrium initiates the moisture movement from inside to outside. So this is the fresh concrete with lightweight aggregate. So what happens when the hardened concrete, once the hardening takes place, how it happens? So here it is explained. So once the concrete gets hardened, so the outside hydrated cement paste consists of some huge number of capillary pores, and sometimes it consists of some unhydrated cement particle. And if we use this high performance concrete, naturally the outer periphery of this hydrated cement paste is also sealed by some secondary CSH gel. So it is very difficult for the outside water, that external water, to get inside to reach that unreacted cement particle, right? So that outer system prevents it. But what happens, this inner system, this lightweight aggregate with the spongy structure, with the pore structure, because of this variation of this hygral equilibrium, slowly it transports from inside to outside. Because it is not moving, this CSA gel, it consists of some capillary pores, and the capillary pores consist of capillary water. That capillary water means not pure water, as I told you. So when cement mixed with water, it is converted into ionic solution. It consists of some n number of ions. So what are all the mineral consist of that chemical substances? All these will be dissolved in this pore solution. It consists of some different types of ions within it. So those solution and all, it is filled in the capillary pores as well as in gel pores. So capillary pores are like our minute pipes, capillary pipe system. It follows our capillary rise principle, suction, meniscus. All these terminologies are associated with capillary pores. So due to this various factors, this capillary suction takes place.
Thank you.
And
मॅडमने सांगितलं तुम्हाला आपण
so
कॉलेजमध्ये
due
बाहेर
to this
पडतो
capillary suction,
वॉशिंग कॉलेज
this capillary suction,
दोन लाईनची दोन वया का
so excuse me, kindly mute your phone. So one of you please. I think you have forgot that one. Kindly mute your phones. Yes, okay. So due to this capillary suction, this water within the aggregate is taken out, right? This happens in the hardened concrete with lightweight aggregate. Similarly, in the case of normal weight aggregate, this is not possible, right? So there's a smooth concrete surface, and secondary CSHL formation is also there. It prevents the entry of water. So this transit zone finally ends with this. Sometimes if you use this calcium silicate, additional secondary bosonic admixtures, if you use it, definitely it will strengthen that transition zone. But if you does not use it, the calcium hydroxide leachate is deposited here. It makes it it is less weaker, weaker portion of the system, right? So these are all the scenarios which has happened in the system, right? So self-curing, in the case of self-curing concrete, as shown in the figure, what I have explained here, it starts from the contact zone. The initiation is only from the contact zone. between the self-curing agent and cement paste. Here I'm using a lightweight aggregate as my agent, but it is not a compulsory one that always you should use lightweight aggregate to achieve your self-curing, not like that. So you can use any type of self-curing methods. So if the process initiates with the surface, and you can use any self-curing agent to initiate this process, right? So until this process is initiated, as long there is a humidity difference generates after a certain period of hydration, it will not happen. Only after the initiation of some humidity gradient, so the process initiates. As long as it will be like absorbing the water from the free water available to it, it will take it and it will start hydrating, right? So this is the thing. And while speaking about speaking about the curing agents, there are different types of self-curing agents or compounds are available. So as per the definition, these curing agents are defined as or act as internal water reservoirs. It has high water absorption capacity, and it also has desorption capacity also. It should have both the capacity. It should absorb as well as desorption. So desorption rate as well as absorption rate is under pressure is very, very important for selecting any type of these self-healing agent. Currently, a very popular one is lightweight aggregate and chemical admixtures such as SAP, super absorbent polymer. So it is abbreviated as SAP, and shrinkage reducing admixtures, SRA, and sometimes wood powder is also attempted as self-curing agent because it consists of some micropores on the surface, so that's a very good water absorbent, and it releases the water also, right? So lightweight aggregates including ceramicite, sometimes pumice, are the normally used as self-curing agents. And the SAP, SRA both are capable of having high water absorption, and they have 1,000 times higher than their own weight. See, imagine they absorb water more than 1,000 times of their original weight. So there are two distinct phases you can observe in the SAP that I'll show you later. So this is the internal curing process, curing by getting water from outside, and this is what I have explained. So external water source getting into the aggregate, and whereas in the case of internal curing method, water is available within the system, it is released whenever it is needed. So it is achieved by replacing part of the aggregate by lightweight aggregate or using admixtures. So from inside to outside, self-curing is the process takes place from inside to outside, reducing the autogeneous shrinkage and self-desiccation, especially for the high performance concrete where low water cement ratio is needed, and durability and the workability of self-curing concrete is improved compared with the conventional air-cured concrete, while the mechanical properties may be either enhanced or compromised. So we cannot expect more of like enhancement of this mechanical properties due to this addition of self-curing agents. Performance can be enhanced, right? So the performance can be enhanced, not the strength. Then self-curing concrete has been widely applied in actual practices, mostly bridge decks and pavements. And this is the mechanism. This is like the similar one what I have explained. Here they have attempted fly ash aggregates. So wet porous fly ash aggregates are used, and the same humidity under the same humidity condition under hydral equilibrium. Relative hydral equilibrium is if it is 0, then the same humidity conditions exist between the fly ash aggregates and fresh cement paste. There will not be any movement of absorbed water, right? Once the humidity difference arises, the mechanism starts. So the self-curing process starts up with this difference of humidity. So the difference of humidity conditions between this fly ash aggregates and hardened cement paste initiated. So absorbed water in fly ash aggregate is released into the hardened cement paste to make it facilitate or help the hydrated cement paste to use that one, so that unreacted cement particle, if anything found in that medium or that place, that will take that water and it starts hydrating. So the hydration process is continued even the non-availability of external water. So, and the process ends when it ends. See, the process of water moving out and hydration stop when the high density of hydration products near the surface creates the layer. Even the fly ash particle is surrounded, if the fly ash particle is surrounded by denser particles, and that denser medium, if it prevents the movement of that absorbed water outside, at that stage the movement will be stopped. This is the mechanism, and this is the various phases of water available in the phase. So this is the microstructure of the cement paste. So capillary water is available, and some gel water, that is physically bound water in between the CSA gel is available, and chemically combined water, that is called as non-evaporable water, is also. These are different forms of water taken up by the hydrated cement paste. And according to Power's law, so Power's law is one of the important law, which is it is an invention by Power, so which is used for the measurement of quantity of water which is taken up by the cement system. Based on that, we could fix our, or we can water which is needed, that is water cement or water to binder ratio for effective performance of, in most of the cases, is fixed based on this Power's model. This is a fundamental model which is used for calculating the quantity of water to binder ratio. So according to Power's measurement, chemically combined water, which is also called as non-evaporable water, is 0.23 grams of water is bound per gram of cement during hydration, right? This water is called as chemically bound water, and it is non-evaporable also. So you can evaporate this water only if you heat the system up to 105 degrees centigrade. Until then, this water will not be taken out, right? So it is an integral part of the structure of the gel or CSA gel, right? So on the surface of the gel solid, CSH is a hydrated silicate, calcium silicate hydrate gel. It is a semi-solid, and on the surface a small amount of water is absorbed. On the surface, it is approximately 0.19 grams of water per gram of cement reactor, right? So this physically bound water or gel water has a range of, it is also taken up for the hydration process between the various relative humidity ranges between 0 to 100, right? So it needs some to activate this water to enter into the chemical reaction. It needs some energy, right? Some energy is needed. That energy may be created or favored to this gel water. That may happen between various humidity levels, 0 to 100. No humidity difference, fully saturated. There is a huge humidity difference, that is extreme 100. So in between there may be something that may favors or initiates this bound water, again that will be taken up by the unreacted cement particle. So unbound water in the cement paste is called as free water or capillary water. So I shown you in my previous slide that different forms of water. So capillary water is called as unbound water, right? So it consists of small capillary pores, right? Small, very nano diameter pores. That is where it acts as a channel. These capillary pores are, sometimes it is more helpful for in the case of self-curing concrete, whereas in the case of this normal concrete, once this chemically bound water in the capillary pores are utilized, it becomes a channel for the entry of harmful substances into the concrete. So sometimes it is more helpful, sometimes it is more harmful. So this capillary water present in the capillary pores are also being used. So once capillary pores are freely accessible for cement hydration, that will completely taken out. Here, the relative humidity is one of the important parameter. So that based on this relative humidity, the reaction products formed during the cement hydration is taken or considered, whether it is from this no, from the internal source due to internal cooling or from the external cooling. So that relative humidity plays a vital role, especially in the self-curing system. So this is the Powers model. So let me check the time. Let me take some 5 more minutes to complete this, right? So here, when the water cement ratio is about 0.2, right? There is not enough capillary water for hydration of the cement. Right, so if 0.42 means there is the water may be available fully for the system for the hydration. So cement hydration requires that the produced, calcium silicate hydrate contains should have certain porosity. So according to Powers law, some water cement system is there. Some water, majority of the depends upon the degree of hydration. If it is completely hydrated system, some water will be taken up for formation of CSH, and some pores taken up these water as gel water, and some water is taken up by the system as capillary water. Right. So in the case of a sealed system, like in the case if the water cement ratio is less than 0.42, how the quantity of water taken up by the system is naturally the nearly only some 75% of this water only taken up by this system, right? So this Powers model. I suggest you this. There is a lack of time. I could not explain much on this Powers model. So this Powers model, those who want to pursue research on this self-curing concrete, so you focus more on this Powers model to study in detail about the transport of liquid, transportation of water within the system using this Powers model, how it happens, what is the mechanism and other things. So once you understand these basic concepts, that will help you to to identify a better self-curing system to get maximum efficiency. So what are the current progress of self-curing concrete? Many researchers have been done on self-curing concrete. Mainly they have focused on 3 problems: type of curing agent, and how much curing agents are needed. This is one area of research. And second area is to what extent the self-curing reduces the shrinkage and enhances the durability. This is another area of research. Then third is whether self-curing compromises the workability and mechanical properties of concrete or not. So if you search on the literature on self-curing of concrete, so major research papers are available, only majority of the papers are available, can be classified only on these 3 domains. So those who are pursuing research can do a deep research survey, elaborate research survey to identify the technical gaps, what is mentioned in these three domains, and further problem identification can be done for your research. So this is a dry and a swollen sap. As I told you, this 1000 times can absorb more water than the original one. So there are some challenges. So because of the variety of complex chemical reactions and physical changes in the cement hydration process, the microstructure of the cement-based material undergoes The transformation from suspension, viscous liquid into a solid spherical. So that is a transformation, gel form to finally a hard form. So there is a transformation stage. In between the transformation stage, there are many mechanisms has been taken place. So understanding those mechanisms is very, very essential. So the hydrating materials are usually subjected to autogeneous shrinkage and thus to cracking risk. So in addition, the final properties including mechanics and durability are inherently controlled by the microstructure of the cement-based materials. And the microstructure consists of solid and porous phases, and the spatial and topological arrangement of these phases is ultimately responsible for the strength and transport properties of the cement paste. So the transport properties of the cement paste is very, very important. Those who want to do research on self-curing concrete. And one important topological parameter is the connectivity, percolation of phases. Only otherwise there is no connectivity or percolation. The transport or movement of water from the self-healing material to the unreacted cement is not at all possible. So the connectivity, network, percolation, transport properties of the cement paste are very, very important parts here. So the percolation of phases is interpreted as alpha. When alpha is 1, it indicates that phases is fully connected. When alpha is 0, it indicates that no connected pathways are there. So the percolation theory can be applied to explain the macroscopic performance of mechanics and durability, and transport properties such as ionic diffusion, fluid permeability, and depercolation of capillary pores. So all these things develop the strength of the system. So this is power is what. So this is absorption and desorption of self-curing water. So I leave this study to the audience. They can go with this powers model, absorption and desorption of self-curing water. All these things for their future research. And this is a model SEM analysis, three-dimensional continuum concrete microstructure with 50% replacement of fine aggregate by lightweight aggregate, right? This is one example case study, so I could not continue the presentation due to lack of time. So you can read with some good interesting literatures which is available in the net. You can go ahead with that work for your future research, but the understanding domain which is very much needed is transport mechanism of the cement, hydrated cement paste is very, very essential. So applications, there are a number of applications, but most of the early age cracking occurs in the pavements, beach decks, slabs, etc. So this area is quite very much be interested to the transportation structural systems, infrastructure systems. It is very well be appreciated. So thank you very much. Let me close my session.
Participants, if you have any clarifications, you can ask.
So if you have any queries, you please mail to Mr. Manimadhu. He's doing part-time PG in our college. So you mail to him so that I can give reply through him for your queries. You can get the mail ID from the organizers. Don't worry if you do not have any doubt now. Ask the queries through mail later.
Thank you, madam.
Okay, thank you, sir. Thank you very much.
Madam has covered on the topic self-curing and bacterial concrete. Under bacterial concrete, Madam covered autogenous and autonomous self-healing concrete, materials used for this one, and also different causes like physical, chemical, and mechanical one, and also the steps, corresponding steps involved. Uh, there are two process, chemical self-healing as well as biological self-healing. That also it was covered in a detailed manner. Under self-curing concrete, Madam covered how to achieve and place where to use the self-curing concrete, mechanism of self-curing process, and applications of self-curing concrete. So she covered in a detailed manner. She is having very vast experience in this area. If you have any clarifications or doubt, you can mail to her. You can get clarified. Thank you very much, madam. Thank you for your continuous support.
Thank you, sir. Thank you very much
Thank you, madam.
for giving me an
Dear,
opportunity also.
dear participants, now we are coming to the end of the session. Tomorrow, the third day session will start. That will start sharply by 9 a.m. All of you, please join 5 minutes before the start of the program. Thank you very much. We will see you tomorrow. Thank you, madam. Thank you, participants.
Thank you, sir.